Ever wondered how we pinpoint the exact sweet spots or turning points on a roller coaster track, or the highest and lowest points of a ball thrown in the air? Today, we're diving into calculus to find these critical points for a specific function. Our journey begins with this function. F of x equals 2x cubed minus 9x squared plus 12x minus 4. To find its critical points, our first step is to find its derivative, f prime of x. Think of the derivative as the function's speedometer or instantaneous slope at any given point. Now, to find where the function might pause or change direction, we set this speedometer to 0. F prime of x equals 0. This equation looks a bit messy, so let's simplify it by dividing every term by 6. Next, we factor this simplified equation. We're looking for two numbers that multiply to positive 2 and add up to negative 3. Those numbers are negative 1 and negative 2. This gives us two possible values for x equals 1 and x equals 2. These are our critical points. To visualize this, let's graph our original function and mark these critical points. And that's it! We've found the critical points of our function. These are the points where the function might pause or change direction, just like the turning points on a roller coaster track, or the highest and lowest points of a ball thrown in the air.